Okay, so we finally can do a whole free response question. Now that we're basically done with derivatives, it opens up a lot more. So this is one real free response question, so it's worth all 9 points. And you could do all the parts this time. All right, so let's consider this curve. It was an implicit derivative. So they tell you what the answer is. You want to show that this is your derivative. So you do need to show all the steps. So remember, every time you do a y derivative, you multiply it by dy dx. So x squared would be 2x, and then plus another power rule, so 8y times dy dx. 0, and then this is a product rule. So I'm going to have 1 and 2. I keep the 3 with the x. So 1, the derivative of y is 1 dy dx. d2 plus 2, and then d1 is just 3. Okay? And so now your goal is to get dy dx alone. So you can move it to either side. What I notice is that the 8 is positive, so I'm going to move the dy dx to the left and the 2x to the right. So 8y dy dx minus 3x dy dx equals 3y minus 2x. So then we're going to factor out a dy dx, and you would get 8y minus 3x equals this. So then dy dx equals this divided by that, because it's being multiplied. And they should match up. Okay? Part B, show that there is a point P. So we do want a point with an x-coordinate 3, at which the line tangent to the curve P is horizontal. So remember, horizontal means that my derivative is equal to 0. All right. So they want you to find the y-coordinate of P. So I'm going to write P, and we know x is 3, and we're going to find y. So if I know that my tangent line to P is horizontal, this is my curve, and the horizontal means my derivative is 0, which means my numerator is equal to 0. So I know that 3y minus 2x equals 0. Remember, undefined or vertical would be the denominator set equal to 0. So if we know x equals 3, we're going to substitute that in. So 3y minus 6 equals 0. Add 6. Divide by 3. So y equals 2. And that's all they wanted, okay? It does say show, all right? Part C, it says find the value of the second derivative at point P. So we know x is 3 and y is 2. So I'm going to put that in there because anything in this part needs to be written. We won't go back and look at other parts. And then we're going to find out if it has a local max or min using the second derivative. So the second derivative is going to be a quotient rule. So remember, you do need to take the derivative of the left side. So I'm going to write this. So I can't go back and forth. I get dy dx, what was it? 3y minus 2x all over 8y minus 3x. Yeah. Okay. So you wouldn't typically have to rewrite this, but I can't see up and down. So the derivative of the left is that notation. Please use that. So it's set equal to something. And then we're going to do a quotient rule. So low d high, and it's still going to be an implicit derivative, remember? So d high would be 3 dy dx minus 2. Low d high minus high. And then d low is 8 dy dx minus 3. All over low squared. Okay. So find the value of our derivative. Now notice, when we have dy dx, we actually need to substitute this value in. So I'm just going to use green. So x is 3 and y is 2. So the value of our derivative is 6 minus 6 is 0, which it should be, over anything. It doesn't matter. Who cares? Which is 0. So what that does is, because this is 0, it wipes that term out. Okay? But it does say show. No, it doesn't. Never mind. Okay, so x is 3. And this is just really a matter of keeping track of everything. And y is 2. All right, so now we're going to clean this up. So our second derivative, this is easier on paper, but that's okay. So we get 16 minus 9 is 7 times negative 2. Can only do so much at one time. What's that? 6 minus 6 is 0. 0 times all of that is still going to be 0. All over what? 16 minus 9 is 7. 7 squared is 49. So we get negative 14 over 49. And you technically don't have to reduce. The AP gives you full credit, as will I. Multiple choice will be reduced. So divide by 7. So the value of our second derivative is negative 2/7. Okay? And remember, that is at when our first derivative was equal to 0. So that's a critical point. Okay? So now it says, does the curve have a local max, local min, or neither? So since that was our critical point, so I'm going to write that. So at P32 is a critical point since you can write the f prime of x, our derivative equals 0 at P32. And f double prime, our second derivative was negative at 3, negative 2. Remember, that meant if it's negative that we were concave down, and so that's a maximum. Therefore, local max by the second derivative test. Any more room? Second derivative test. So remember, the premise, you had to state it was a critical point in the first derivative and that your second derivative was negative. Those are the two statements together that need to be stated with the second derivative test justification. Okay? All right, so let's look at the grading. So scoring guidelines, it looks like you get 2 points, 1 for your implicit derivative and 1 if you get dy dx alone. Okay? You get 3 points if you set your derivative equal to 0, which is just your numerator. And notice you have to physically show that. Okay? You get a second point if you show that the slope is 0 at 3, 2. And what did it say? Find the y coordinate of P. Now, I always miss this. We just have to show the point 3, 2 lies on the curve, okay? So I missed that in my write-up. I went like I was a student. I would always miss that. Even 20 years later, I just missed that because I think it doesn't seem obvious to me. You need to show that you have that point on the curve, okay? So I would have missed 1 point, which still would have been 8 out of 9 points. So we're going to go back here to part B, and I'm going to x squared. I have to plug it in here, but it needs to be in this space. So, oops, sorry. X squared Where are we at? Plus 4y squared. I'm using the original, equals 7 plus 3xy equals 7 plus 3xy. So we need to show that x equals 3. So 9 plus 4 times y is 2. 7 plus 3 times 3 times 2. So what do we get? 9 plus 2 squared is 4, 16, so 25. 7 plus 9 times 2 is 18. 7 plus 18, 25. Okay, so therefore, P3, 2 is on the curve. Okay, like I said, this is not even the first time I've done this question, and I literally miss it every single year. So even though I had seen the answer key, I still wanted to solve this problem. Like I think 99% of the students would have. Maybe one student would have gotten that. Not me, not even as the teacher. Okay, let's go back to the answer key. Let's see, our second derivative, you get 2 points for that. It is kind of a lot. Okay, so we did that. You get 1 point if you have the value, which the negative 2 sevenths, it doesn't have to be reduced. That's what it's referring to. And the number 1 is your conclusion. So I named the second derivative test. I always do. But they have the same premises here. They don't have to name it. Okay. So just to kind of show you the idea. It is the idea of the second derivative test, though. I don't know why they don't make you name it. I guess that's kind of nice, though. Okay. All right, so there's your 9 points, and I hope you did well. This was a pretty decent one that I think is pretty good. I know we did first derivatives the first quarter, but a lot of students didn't turn in that free response question. So hopefully this helped review implicit derivatives and tie in some of these new rules. Okay, all right, luck.